Hello, this is 3-4 Scientific Notation. Today we're going to learn about scientific notation. So if you've seen a really, really big number, um, then you probably have realized that it's probably too hard to write. For example, if we were dealing with the number of atoms in a given sample, it could easily exceed 1 times 10 to the 23rd. So 1 followed by 23 zeros. That's about a sixth of a mole, right? So how do you deal with that? Well, scientists created scientific notation to help write big numbers. So how does this work? Well, it's a number multiplied by 10 to a certain power. So for example, if we were to write 1 million, which is 1 followed by 6 zeros, that is 1 times 10 to the 6th. So how does this work? Well, if you know how to multiply or divide by factors, divide by 10, you just move the decimal point, right? So for example, if you had 1 multiplied by 10 to the 6th, you move the decimal point to the right. So in this case, it's right here, right? You move it once, two, twice, 3 times, 4 times, 5 times, 6 times. So now it's 1 followed by 6 zeros. So 6 zeros. So that's scientific notation. Now, here are some rules that you need to follow when writing in scientific notation. So, again, this is going to be a number multiplied by 10 to a certain power. First of all, the number here must be in between 1 and 10. The number we'll call x for now. X must be greater than 1, greater than or equal to 1, but less than 10, or less than 10, and less than 10. So, for example, if you had 10 times 10, you just move the 0, put it inside the exponents. So let's see this in action. Say we're going to write 564 in scientific notation. So first of all, we need to put a decimal point somewhere. Well, we need a number that's in between 1 and 10. In this case, 5.64 is in between 1 and 10. So we'll put 5.64. Our original number is 564. We want to represent that in scientific notation. So times 10, we need to know how many zeros we need to add, or how many tens we need to multiply by. So the decimal point used to be here, and then moved once twice. So 5.64 times 10 to the second power. A good way of thinking about this is that look back at your answer. If your answer was bigger than the number that's right here, then your exponent should be positive. Write that down. If the number that you're trying to represent is greater than the number that's inside the scientific notation thing, your exponent should be positive. Okay, great. Now we're going to do, in the case that you're writing a really small number. For example, let's do this first. 0.01. Well, where can we put the decimal point so that the number is in between 1 and 10? Obviously, 0.01 is not in between 1 and 10. Right, it's less than 1. So if we put a decimal point here, then it would fit that criteria. So it's 1 times 10 to a certain number. So now we just have to see how many times the decimal point moved. In this case, 1, 2. So 2. But that's not right, because 1 times 10 to the second, right? 10 squared, that's 100. Right? 1 times 100, that's 100. That's not what we tried to do. Instead, it's 10 to the negative second power. So negative second power does not mean negative numbers. Remember that negative exponents do not mean negative numbers. It means the decimal point is going in the opposite direction as it is in the positive exponents. So this number is the same as this number. Now let's do some practice. I want you to, if you can, in your head or on some scratch paper, tell me, how do you write this number in scientific notation? Pause the video and try that on your own. Okay, assuming that you've tried it on your own, let's do this together. So first of all, where should you put the decimal point so that the number is in between 1 and 10? Well, we can put a decimal point right here. Right, 5.37 is in between 1 and 10. So let's put that there, 5.37. We don't need to put the 0 because it doesn't add anything to our number. Times 10 to a certain power. Well, the decimal point used to be here. So let's see how many times it moved. 1, 2, 3. 3. And now we can look at our thing. You can see that the number we're trying to represent is greater than the number that's here, right? 5,370 is bigger than 5.37, which means our exponent is going to be positive. So it's going to be 10 to the third power and not 10 to the negative third power. Okay, great. Let's do another example before we end this class. I want you to represent 0.00037 in scientific notation. Pause the video and see if you can do that on your own. Okay, let's do this question together. So where can we put a decimal point so that the number is in between 1 and 10? Well, we can put it right here. 3.7 is in between 1 and 10. So we'll write that down. 3.7 times 10 to a certain number. Well, now let's see how many times the decimal point moved. So it used to be here, now it's here. 1, 2, 3, 4. So 10 to the fourth. But is that right? No, it's not. Why? Because the number we're trying to represent is actually smaller than the number that's here. So we actually have to put a negative sign in between our in front of our exponent. So instead of it being 3.7 times 10 to the fourth, it's 3.7 times 10 to the negative fourth. So remember that when writing scientific notation. Okay, great. So now we're going to do some examples where we do the opposite. We're given a number in scientific notation, and we need to convert it into numbers. So say we have 5.3 times 10 to the negative third. How would this be written as a number? Well, just put a bunch of zeros in front, however many you think is you're going to need, and then 5.3. Okay, so knowing that our exponent is negative, meaning our answer should be smaller than 5.3, let's move the decimal point in a way that would decrease the answer. So instead of being 5.3, 0.5.3, 0.053, now we do it 3 times per decimal point right here. So that's 0.0053, right? We didn't actually need the 0. So 0.0053. If it didn't make sense, you can just look at how many times the decimal point and look back at what you hopefully wrote down, which is that if the number that you're trying to represent is bigger than the number that's inside the scientific notation, then your exponent should be positive, and if it's smaller than the number that's inside the scientific notation, then your exponent should be negative. In this case, it is negative, which means the number that we're trying to represent should also be smaller than the number that we are putting inside our scientific notation. In this case, 0.0053 is indeed smaller than 5.3. And also, again, we move the decimal point accordingly, according to the number that's inside the scientific notation, the exponent inside the scientific notation. So we'll do one more example where it is positive. So, for example, 3.7 times 10 to the, let's do 6. See if you can write that down as a number. Let's do this question together. So first of all, 3.7, then add a bunch of zeros at the end because we know the number is going to be bigger than 3.7 because we have a positive exponent, right? So let's move the decimal point accordingly. 1, 2, 3, 4, 5, 6. It's going to be right here. So that's 3, 7, and let's count 1, 2, 3, 4, 5 zeros. So then we put our commas. No, we see that's 3,700,000. Okay, great. So that's all there is for this lesson. Some additional things that you should write is that negative exponents, right? Negative exponents means left 3, positive exponents, right 3. So move the decimal point to the right 3 and left 3. But again, you should always check. Use your common sense. If the exponent is positive, then the number outside of the scientific notation should be greater than the number that's inside scientific notation, and vice versa. So, if any questions, make sure to ask. And yeah, the homework will be in Google Classroom and is due tomorrow, Friday.